The learning objective of this chapter is to introduce the learner to basic boiler fuel oil systems and equipment. Unlike combustion in a diesel engine cylinder, the combustion process in a boiler furnace is a continuous process. Once a flame is established, the combustion will continue until the steam pressure in the boiler reaches the preset value for the burner to cut out. In simple boiler combustion systems, the burner will operate with on-off control. However, in most marine boilers, the combustion rate will vary automatically depending on the steam pressure and the boiler load. You can think of the boiler load as the rate at which the generated steam is being used. Also, unlike the diesel engine, boiler combustion takes place with only a small excess of air, so that there is little unused oxygen, often less than 5%, in the boiler exhaust. This makes the boiler exhaust an ideal source of inert gas for cargo tank inerting on tankers. There are also a number of safety cutouts on the boiler which will shut down the burner regardless of the steam pressure. We will consider some of these later in the chapter. Due to the fact that the combustion process is continuous, once the initial flame is established, boilers can operate on lower grades of fuel than diesel engines. The fuel systems are therefore much simpler, and the fuel requires much less preparation. In most cases, boilers will operate on heated, heavy residual fuel, which has been centrifuged and then passed through fairly coarse filters. There will usually be a facility for cold start on distillate fuel when steam heating is unavailable. A pilot flame is used to ignite the main burner. The pilot flame is provided by a diesel oil burner, which is lit by spark ignition by electrodes and a high voltage supply. On LNG carriers operating with steam propulsion, the boilers are designed to operate either on liquid fuel or on cargo boil-off gas. As has already been stated, most marine steam boilers have automated combustion control. This is mainly due to safety considerations. These combustion control systems can be extremely complex. We will only consider the automatic control briefly in this module. Steam boilers can either be bottom-fired types, with the burner units located in the wall of the boiler, or top-fired types with the burner units located in the roof of the boiler. Usually, for modern boilers, small, low-rated types are wall-fired, and large, highly rated types are roof-fired. The burner itself can take one of a number of forms. Pressure jet nozzle type. Pressure jet nozzle type with steam atomizing. Rotary cup type. The only difference between the two pressure jet nozzle type units is that the latter uses steam to assist the atomization of the fuel, usually for highly rated boilers operating on heavy residual fuels. Click on the buttons to learn more about these types of burners. A pressure jet nozzle type burner consists of a hollow lance with an atomizing nozzle attached to the end. The pressure drop across the nozzle outlet hole creates the conditions for atomization of the fuel to occur. You get a similar effect when you put your finger over the end of a running water hose. The water stream breaks up into a spray. This type of burner requires a high-pressure fuel supply, typically 7 to 21 bar. The basic atomizer tip is usually of two-piece construction, with internal passages for the high-pressure fuel oil to pass through to the outlet hole. They are normally available with different size outlet holes to optimize atomization at different loads. A more complex type of pressure jet nozzle has a control rod which varies the effective outflow rate of the burner, giving a wider load range for operating with a single-sized nozzle. When steam atomization is used, the nozzle has passageways provided to allow steam to mix with the fuel at the nozzle outlet. The steam mixing with the fuel and the rapid expansion of the steam as the pressure drops on exiting the nozzle gives effective atomization of the fuel in the boiler furnace. This gives more complete combustion of the fuel. Much lower fuel pressures are required when steam atomization is used. As an alternative to steam, compressed air can also be used to atomize the fuel. Rotary cup-type burners are usually wall-mounted and can be used for many different boiler sizes, although more commonly low to medium pressure boilers. Low-pressure fuel is fed into a cup which is rotating at a high speed. This causes the fuel to accelerate towards the periphery of the cup. As the high-speed fuel atomizes as it leaves the cup, it is picked up by a primary airstream, which is directed parallel to the outside of the cup and towards the furnace. The air and fuel mix together, and the mixture enters the furnace as a readily combustible atomized mist. A secondary air supply provides the necessary air to ensure complete combustion. Combustion air is usually supplied by a forced draft fan, although induced draft fans can be used. The air enters the furnace through a flap valve or an air register. An air register can take the form of a slide valve, which controls the supply of combustion air to the boiler furnace. The position of the register is controlled to give the air quantity required for the amount of fuel passing through the burner at any given time. The air flows through a diffuser and a swirl plate as it exits the air register, which controls the air movement and ensures good mixing with the fuel as it leaves the burner. This positive mixing means that only minimal excess air is required to ensure good combustion. A steam boiler requires a certain degree of monitoring and alarm and shutdown protection to ensure safe operation. The two main concerns are always low water level and high steam pressure. A very low water level can result in overheating, resulting in boiler failure. This is often termed low level. High steam pressure can lead to rupture of the boiler. Early detection of both of these conditions will result in an emergency shutdown of the burner unit before any damage could occur. The list shows the main parameters that are monitored for a boiler fuel oil system. Fault condition of any of these will result in emergency shutdown of the burner unit. All boiler fuel systems that you sail with will have an automated sequence to control the combustion operation. A typical combustion control sequence will have the following basic elements. The sequence will be initiated when the steam pressure falls below the burner cut-in point. The first part of the sequence will be the furnace pre-purge. Combustion air fan starts. Air register full open. Furnace purge for predetermined time. Once the pre-purge is complete, the ignition burner is activated. Air register to ignition setting. Fuel to ignition burner. Spark igniter operates. Once the ignition period is complete, the main burner will activate. Main burner fuel on. Once the main flame is correctly established, the ignition burner will shut down. Flame established. Check. Ignition burner fuel off. As the steam demand and pressure vary, the burner unit will modulate. Air and fuel automatic adjustment to suit load condition. If the steam pressure reaches the cutout point, the burner unit will shut down, with the fan continuing to run for a short time. You should always make sure you are familiar with the actual system fitted to the boiler on your vessel. As with any fuel oil system, routine maintenance of a boiler fuel oil system will require regular cleaning of filters and prevention of leaks from joints and valve glands. In addition, the boiler burners and combustion air equipment, such as diffusers and swell plates, have to be cleaned regularly. Care must always be taken to ensure that burner nozzles are in good condition and that nozzle holes are not blocked or damaged. The various shutdowns should be tested on a regular basis to ensure correct function. Remember, correct maintenance and operating procedures will ensure safe operation. In this chapter, we have looked at the basic requirements for a boiler fuel system and have considered some of the main burner types that you are likely to sail with. Boilers and the associated systems are considered as high-risk equipment because of the dangers of furnace explosion and boiler overpressure. The high temperatures and pressures involved require that the operator is completely familiar with the safe operating procedures for the equipment. You should always make sure that you study the manufacturer's and shipboard instructions before operating such equipment. Before moving on to the assessment chapter, try the questions in the following pages to check your understanding so far.